What if the reason scientists can't tell you what this object is made of is that it isn't made of anything they recognize? On July 1st, 2025, a half-meter telescope perched in the mountains of Chile caught something screaming in from the black between the stars. They called it 3I Atlas, the third interstellar visitor humanity has ever confirmed, and it was already blazing bright at 4.5 times the distance between the Earth and the Sun. That brightness, from something so impossibly far away, was the first thing that didn't add up. And it would not be the last. Because when astronomers pointed their instruments at it and tried to read its chemical fingerprint, the signatures they expected, the telltale gases that would mark it as a comet, an ordinary dirty snowball from some distant star, simply weren't there. All they found was a strange reddening of the light. No clear composition, no clean answer. Just an object that refuses to be what it should be. This is where a Harvard physicist enters the story. Dr. Avi Loeb, one of the most decorated astrophysicists alive, heard about this thing and within hours knew something was wrong with it. He cancelled his July 4th vacation, sat down and wrote a scientific paper that was accepted for publication within days, arguing that if this object is natural, the numbers describing it break in ways that should be impossible, a size that shouldn't exist, a composition that won't resolve, a trajectory with 1 in 20,000 odds. Before we go any further, subscribe and stay with me, because the deeper you go into 3I Atlas, the stranger it gets. Let's begin. Let's start with what we're actually dealing with, because 3I Atlas isn't just another rock tumbling past. It's only the third object from beyond our solar system that humanity has ever confirmed. The first was Oumuamua, back in 2017, that bizarre, flat, tumbling thing that showed no comet tail and yet accelerated away from the Sun in a way nobody could fully explain. The second was Borisov in 2019, a far more familiar sight, an icy comet that just happened to be moving too fast to belong to our Sun. And then, 8 years and only 2 visitors later, this one arrived. 3 objects in nearly a decade. That's the entire sample size for everything we know about what drifts in from interstellar space. Now here's the first detail that made scientists sit up. 3I Atlas was discovered by a small telescope only 0.5 meter across. That sounds like a technicality, but think about what it means. A small telescope can only spot an object that far out if that object is genuinely, unusually bright. And 3I Atlas was bright at 4.5 times the Earth to Sun distance, out in the cold dark where sunlight is thin and objects are supposed to be faint and hard to find. Something that far away has no business shining that clearly. And here's the part that borders on embarrassing for the biggest telescope on Earth. That very same month, the brand new Vera Rubin Observatory was being inaugurated, a revolutionary machine built specifically to hunt for exactly these kinds of objects. It got scooped by a telescope a fraction of its size. When the Rubin team went back and combed through their own earlier data, they found it. Images of 3I Atlas, sitting there, captured before anyone had noticed. The object had already been staring back at us, and we'd missed it. But that brightness, the thing that let a small telescope catch what a giant one overlooked, wasn't just a lucky break. Because when Avi Loeb pulled on it, the whole picture started to unravel into something that made no sense at all. Here's how you unravel it. When we see an object shining in space, we usually assume it's just reflecting sunlight, the same way the moon does. So you can work backwards. You know how much light is hitting it, you measure how much is coming back, and that tells you how big it has to be to bounce back that much glow. Run that calculation for 3I Atlas, treating it as a simple solid rock, and you get a staggering answer. To be this bright, it would need to be roughly 20 kilometers across. 20 kilometers. Hold on to that number, because it's about to break everything. Remember, Oumuamua. That first interstellar visitor was around 100 meters across. And here's the problem. In the universe, small objects vastly outnumber large ones. For every single 20-kilometer object drifting between the stars, there should be something like 1 million objects the size of Oumuamua. 1 million. So if 20-kilometer interstellar rocks were common enough that one just happened to wander into our solar system, then space should be absolutely swarming with the smaller ones. We should have found 1 million Oumuamuas by now. We found one. The math gets worse the harder you look at it. Loeb ran the numbers on what it would actually take for a rock this size to show up as often as we're seeing them arrive. The answer? Interstellar space would need to hold nearly 10,000 times more rocky material than everything we understand about how planetary systems form says is out there. The galaxy simply doesn't have that many giant rocks to throw around. A 20-kilometer natural asteroid arriving here is not just unlikely, it is very nearly impossible. So Loeb reached the only conclusion the numbers allow. If 3I Atlas is natural, it cannot be 20 kilometers of solid rock. It has to be small, less than a single kilometer across. 20 times smaller, 8,000 times less massive. But that fix only works if something else is doing the shining, a vast cloud of dust surrounding a tiny nucleus, catching and reflecting far more sunlight than the little core ever could on its own. In other words, for the numbers to hold together at all, 3I Atlas has to be a comet. So scientists went looking for the comet, and that is where the real trouble began. Here is how you catch a comet in the act. Every comet has a chemical signature. As it warms, it sheds gas and dust, and that material leaves fingerprints in the light, molecular signatures you can read like a barcode when you split the light into a spectrum. Point a good instrument at a comet, and those fingerprints show up. The specific gases, the evaporating ices, the chemistry of a dirty snowball coming apart in the sunlight. That is how you confirm what you are looking at. So, astronomers took the spectrum of 3I Atlas, fully expecting to read the barcode of a comet, and the fingerprints were not there. The molecular signatures that define a comet's tail, the gases that should have been screaming their presence, simply did not appear. What they found instead was almost nothing to work with, just a reddening of the reflected sunlight. The light coming back was redder than the light going out, and that was it. That was the whole clue. And here is why that single detail refuses to resolve. That reddening could mean two completely different things, and the data cannot tell you which. On one hand, it could be a cloud of fine dust scattering the light, exactly what you would expect from a comet, which would fit the small nucleus picture perfectly. But on the other hand, it could simply be the surface of the object itself being red. We see red objects all the time in the outer solar system. A naturally red rock and a dusty comet can look identical through this particular window. The barcode that was supposed to settle everything came back blank. There are hints, to be fair. When you look at the images, there is a faint fuzz around the object, and its shape on the screen is just slightly larger than a background star, which shows up as a perfect pinpoint. That is the kind of soft blur you would associate with a comet's coma. But it is a whisper, not a confirmation. And this is the heart of the whole mystery. By now, with an object this bright and this well studied, you would normally expect a clear answer, comet or not. The fact that we still cannot say what 3I Atlas is made of is exactly the thing that makes no sense. It is showing us just enough to suggest a comet, and withholding everything that would prove it, which leaves us at a fork. As it swings closer to the Sun, the heat will climb, and if it is truly a comet, it should erupt, evaporating vigorously, finally showing the fingerprints it has been hiding. Or it will not. And if it stays silent, the mystery does not just linger, it deepens. Now set the composition aside for a moment, because even if you knew nothing about what 3I Atlas is made of, the way it's moving through our solar system is strange enough on its own. And this is where the numbers start to feel less like coincidence and more like a pattern. Start with the plane it's traveling in. The planets of our solar system orbit the Sun on a roughly flat sheet, like marbles rolling on a tabletop. An object arriving from interstellar space could come in at any angle at all, tilted, plunging, sideways, from anywhere in the sphere of the sky. And yet 3I Atlas arrives within about 5 degrees of that same flat plane, gliding in almost perfectly aligned with the planets. The odds of that happening by pure chance? Around 0.2%. But that's just the opening. Play with the timing of its arrival, and you find something even harder to shrug off. Out of all the ways this object could have been scheduled to pass through, only about 1 in 20,000 arrival times would carry it this close to the inner planets, threading past the neighborhoods of Jupiter, Mars, and Venus the way it does. 1 in 20,000. That's not the kind of number you brush aside as luck. Then there's the timing of its closest approach to the Sun, which it reaches on October 29th. At that exact moment, the critical moment, Earth will be sitting on the far opposite side of the Sun. We will literally be unable to watch the most important phase of its journey. It vanishes behind the glare precisely when we would most want to be looking, and consider where it came from. 3I Atlas approached from the direction of the galactic center, the crowded heart of the Milky Way, packed with so many stars that spotting a single dark object against that backdrop is nearly impossible, which is exactly why we caught it so late. Here's the detail that closes the trap. When 3I Atlas reaches its closest approach, it will be moving at 98 kilometers per second relative to Earth. That's 3 times faster than the top speed of any chemical rocket we can build. Even if we wanted to chase it, to launch something to fly alongside and finally see it up close, we cannot. It's simply moving too fast for us to reach. And so Loeb raises the possibility that lingers over all of this. If something wanted to slow down, to shed speed and let the Sun's gravity capture it, the perfect place to perform that maneuver, completely hidden from every telescope on Earth, would be exactly there, behind the Sun, in the dark, at the one moment we cannot see. So where does all of this actually leave us? Let's be fair, because the majority of scientists looking at 3I Atlas land on the ordinary explanation, and they have good reason to. It's an interstellar comet, they say, and the missing chemical fingerprints aren't a mystery at all. They're just early. The object is still far from the Sun, not yet hot enough to erupt into the gases we're looking for. Wait until it gets closer, and the barcode will appear right on schedule. That's the sober read, and it may well be correct. But then there's the other read, the one that's harder to dismiss the longer you sit with it. Because it isn't any single strange fact that unsettles people. It's the way they stack, the impossible brightness, the size that shouldn't exist, the fingerprints that won't appear, the trajectory threaded through the planets at 1 in 20,000 odds, the closest approach hidden behind the Sun at the exact moment we can't watch. Any one of these is a coincidence. All of them together start to feel like something else. And here's a detail that sends a genuine chill up the spine. More than 50 years ago, Arthur C. Clarke wrote a novel called Rendezvous with Rama, in which an interstellar craft drifts into our solar system. He imagined it as an enormous cylinder, roughly 20 kilometers across and 50 kilometers long. Now remember, the size 3I Atlas would have to be if it were a solid object. 20 kilometers. The numbers line up almost exactly. Life imitating fiction, or just a haunting coincidence, you can decide for yourself. This is why Loeb argues we shouldn't reflexively laugh the idea off. When a genuinely anomalous object enters our own backyard, dismissing the possibility before we've looked is its own kind of failure. And here's what raises the stakes even higher. 3I Atlas is not the end of anything, it's the beginning. That new Vera Rubin Observatory is expected to find as many as 50 interstellar objects over the coming decade. A fourth is coming, a fifth, a sixth. Soon we'll stop giving them names and just number them as they arrive. For the first time in history, the tools are finally in place. Hubble watching, Webb's infrared eyes ready to read their heat, and one day, perhaps, interceptors waiting to fly out and meet them. The flood is coming, and 3I Atlas is the first test of whether we're ready to understand what's in it. The next 2 months will tell us which story is true. So we studied it. We pointed our best instruments at the third visitor ever to reach us from beyond the sun, and we came away unable to say the simplest thing about it. What it's made of. Not comet, not rock, not for certain. Just an object that shows us fragments and hides the rest. And now everything hangs on the next few weeks. As 3I Atlas falls toward the sun and the heat climbs, one of two things happens. Either it erupts, finally, into the roaring, evaporating glow of an ordinary comet, and this whole mystery collapses into something we've seen 1,000 times before, or it stays quiet, and every strange coincidence we've stacked up gets a little harder to explain away. Here's the part I find impossible to look away from. We win either way. If 3I Atlas turns out to be a comet, then we've been handed something extraordinary anyway. A pristine fragment of another star system formed around a distant sun billions of years ago, delivered right to our doorstep without our ever having to leave home. And if it isn't a comet, if it's something else entirely, then we may be looking at the single most important object humanity has ever encountered. There is no boring outcome here. And maybe that's the real lesson of 3I Atlas. For too long, we've assumed that everything falling in from the dark is just stone and ice, that the sky holds nothing but rubble. This one object, bright where it shouldn't be, silent where it should speak, aligned where it should be random, is quietly telling us to stop assuming. Because this is only the first. Dozens more are coming, and each one is a chance to be surprised. The universe is vast, and it is still full of things we haven't imagined. 3I Atlas is proof that we've barely begun to look. If you want to be here when the next one arrives, subscribe and stay with us. The sky is about to get a lot more interesting.